Luxury snake leather doesn't begin in fashion houses. It starts in tightly regulated environments where climate, species biology, and international law intersect. Only specific snake species approved under global wildlife agreements are legally used for leather production. Today, most luxury brands rely on farm raised snakes. This reduces pressure on wild populations while ensuring consistent skin quality, traceability, and ethical oversight, critical for both conservation and manufacturing reliability. Not all snake skins are suitable. Scale symmetry, size, and age determine whether a skin can withstand tanning without tearing. These biological factors directly affect final bag durability. After processing, skins are carefully removed and immediately preserved. Speed matters here. Delays allow bacteria to attack collagen fibers, permanently weakening the leather. Salt draws out moisture while stopping microbial growth. This stabilizes the skin during transport, essentially freezing biological decay before tanning begins. Each skin is graded. Even a single damaged scale can affect where that leather may be used, determining whether it becomes a handbag panel, a strap, or is rejected entirely. From here, preserved skins move through a cold chain logistics system to tanneries. Temperature and humidity control ensure the leather arrives exactly as nature and regulation intended. Snakeskin isn't just exotic, it's structurally different. Unlike cowhide, which relies on dense fiber thickness, snakeskin gains strength from its scale architecture. Each scale overlaps like roof tiles. This design allows flexibility in one direction while resisting tearing in another, an evolutionary solution refined over millions of years. The outer scale is made of keratin, while beneath it lies a thin but dense collagen network. During tanning, this collagen must be stabilized without separating the scales above. Snake skin stretches unevenly. Along the body length, it's strong. Across the width, it's fragile. This directional behavior dictates how patterns must be cut later. Belly scales are thinner and more decorative, but also the most vulnerable. Without understanding these zones, finished luxury bags would fail under daily use. Snakeskin has biological memory. Left untreated, it curls back into its original form. Industrial processes must later erase this memory without damaging scale adhesion. Cowhide forgives mistakes. Snakeskin does not. Its thin structure leaves no margin for error. One wrong chemical balance can destroy weeks of work. To transform this fragile biological material into luxury leather, the first challenge is rehydration, carefully reversing preservation without waking decay. Preserved snake skins arrive biologically dormant but not dead. Inside, collagen fibers are dehydrated and fragile. The goal now is to reverse preservation without restarting decay. Before soaking begins, technicians assess stiffness, salt penetration, and scale condition. This determines soak duration, water chemistry, and agitation speed. Pure water isn't enough. Controlled bactericides prevent microbial growth while enzymes gently loosen fibers, mimicking the skin's original biological state. Submersion must be gradual, too fast, and scales lift, too slow, and rehydration becomes uneven, creating weak zones invisible to the eye. As salt dissolves, moisture re enters collagen fibers. This re-expands the internal structure, restoring flexibility without breaking scale adhesion. Temperature and pH are tightly controlled. Even a small deviation can activate bacteria or weaken keratin, permanently damaging the skin. Properly rehydrated skin bends smoothly, with scales laying flat. This flexibility is the foundation for every mechanical process that follows. Now stabilized and alive again, the skin is ready for permanent transformation, where chemistry will lock flexibility in place forever. Tanning is the point of no return. This is where fragile, organic skin becomes leather, resistant to decay, moisture, and time. Untanned skin will rot, shrink, and harden. Tanning chemically stabilizes collagen fibers, preventing bacteria from consuming the material while preserving flexibility. For luxury snake leather, chrome tanning is often chosen. Chromium salts bond with collagen at a molecular level, locking fibers into a stable, flexible structure. Drum speed matters. Too aggressive and scales detach. Too slow and chemical penetration becomes uneven, creating hidden weak spots. As pH shifts, collagen fibers chemically lock into place. This moment determines softness, tear resistance, and long term durability. Snake skin cannot be treated like cowhide. Its thinner structure demands gentler chemistry, shorter cycles, and constant supervision. After tanning, technicians check scale adhesion immediately. Failure here means the leather will peel months later, unacceptable for luxury goods. Now, chemically stabilized, the leather must be mechanically shaped, flattened, dried, and disciplined into a form suitable for precision manufacturing. Even after tanning, snake leather behaves like skin. It curls, twists, and remembers its original form. Left untreated, it's impossible to manufacture with precision. Vacuum drying removes moisture evenly while pulling the leather flat. This prevents shrinkage and stops scales from lifting during evaporation. Each scale must lie perfectly flat. Once dried, their position becomes permanent, defining the leather's final appearance and durability. Heat speeds drying but risks brittleness. Air drying preserves softness but takes time. Luxury tanneries often combine both to balance speed and quality. Even microns matter. Thickness calibration ensures uniform strength, allowing bags to feel delicate while surviving daily stress. This step erases biological memory. Once fixed flat, the leather no longer tries to return to its original shape. Technicians now inspect for lifted scales, uneven thickness, or micro tears, defects invisible before drying. Corrected and stabilized, the leather is ready for color where science meets art. At this stage, snake leather has strength but no identity. Color will define its character, value, and visual depth. Unlike smooth leather, snake skin absorbs dye unevenly. Each scale behaves like a separate surface, demanding absolute control over chemistry and timing. Drum dyeing pushes pigment deep into the collagen, creating color that won't fade or peel with wear. For gradients and depth, artisans hand spray color. This preserves scale highlights while adding dimension impossible for machines alone. Luxury finishes, metallic pearl or matte, are surface engineered. They enhance light reflection without sealing the leather shut. Edges are sealed to prevent scale lift. This invisible step protects the leather years after the bag leaves the factory. Protective coatings guard against sunlight and humidity, two silent enemies of exotic leather. Now complete, the leather is no longer biological material, it's a luxury surface ready for precision engineering. A bag design is only a concept until it meets the leather. Snake skin forces designers to adapt patterns to biology, not the other way around. Scales run in a single natural direction. Panels cut against that flow will fail faster under stress, especially